Oh, hey guys. Um, I'm here with you with my plants that I'm watering now. Where's the water? I don't know. But today I'm going to be talking with you about photosynthesis and how light reaction and dark reaction works on these guys and make them really big and strong, like milk. All right. You know what? These plants are not good enough for me to show you, so I'm going to find a test subject.
Hello?
Oh, I caught one.
Is
My
that
trap
anyone
actually got one.
there?
Let's go, guys.
Hello? I need out of this trap.
My trap got him, guys.
Oh my shit, what happened here?
I don't know. You fell in. You're kind of weak. Alright, okay, man.
Alright.
Okay, see this, right? I need you. Okay, I need you to put this in me right now.
Okay, alright.
Alright, right there. Yeah, right there.
Okay,
Right
alright. Okay.
Okay, listen, buddy. I'll let you out. But first, we need to put some sun on you, okay?
Okay,
You look kind of weak.
Alright, whatever you say, Jimmy.
Let's go.
Alright, let's go, Jimmy. Okay. Are you sure about this?
Yes.
Am I okay looking?
Yeah, you're okay. You're okay now.
Oh my goodness, thank you. Oh, I'm kind of nervous. Are we gonna get 100%, you think?
Maybe.
Okay, alright.
Alright, see, now the sun is directly towards him, right? And, now he's a pretty flower.
I'm a pretty flower.
And
I'm a pretty flower.
now we're going to see how the sun reacts with the light of the flower. But you don't know what it looks like right now because you can't see it happening. But we're going to go inside this, deep inside of this, right?
Oh.
Let's go. Hey, hi, how you doing? It's your host, Jimmy. You know, that guy with the glasses, the Asian, that guy, the cool cat, the cool slang danger, I'm the host. And with my other two colleagues, my two partners, my two crime and actually my bad cop, good cop, I'm the neutral cop, and yeah, Taylor Little and Kevin. And why is Kevin smaller than me and Taylor? Why are they both smaller? Wow, I must be a giant. But anyways, our thing is about photosynthesis, and you know what? It's not any photosynthesis. It's gonna be about the light reaction and the dark reaction, and what's the difference of them, and what's the connection they can make together, right? And before you say anything, they are stars, those thingies beside the moon. Yeah, just leave it as stars. So we're gonna see how the plant turns into this buff ass one, okay? Damn, it lifts. Let's get started.
Alright guys, let's get started here. I'm the bad cop Taylor Little, teaching you about the light-dependent reactions. Basically, we're gonna start off with a pretty looking sun. So very bright, so nice like, wow. It's rays of sun are gonna hit our test plant here, and if we magnify that a little bit closer and more specifically, the light rays are actually hitting the chloroplast. Inside the chloroplast, we're gonna wait for Jimmy to just speed up a little bit. Jimmy. Oh, inside the chloroplast, we have the stroma, which is just empty space inside the chloroplast, and then we have the stacks of grenum. Each of these stacks of grenum have a couple of thylakoid discs. I guess we can call it the thylakoid disc. Oh, they're so very nice. Oh, Jimmy. Oh, Jimmy. Oh, okay. He's still red. Okay, here we go. What else we got here, Jimmy? All right. It looks like. Oh, oh. Inside of the thylakoid discs here, the light rays are going to hit the thylakoid membrane or hit the thylakoid discs, and then inside the thylakoid disc, they're also going to hit PS1 and PS2, and also the membrane. Uh, and then light rays are hitting PS1 and PS2 simultaneously, and then the antenna complex is going to absorb that light to the reaction center, and then PS2 is going to send its electron through the electron transport chain. Very nice writing, Jimmy. Oh, good job. All right. It's going to release some energy so that hydrogen ions can enter the thylakoid membrane. Uh, and that's all very quick and nice like. Now, it's going to bounce back into the electron transport chain to PS1. Now, PS1, its own antenna complex, is going to absorb the light and then to the reaction center, and then it's going to travel through its own electron transport chain, as Jimmy will soon draw here. He's going to go party. And then he's going to go traveling, he's going to bounce back and forth, and then he's going to end up outside into the stroma again. Since it's electrically charged, electron, that makes sense. And it's gonna go back into the stroma. Oh, the house party of the stroma. Oh, so very nice, Jimmy. So nice. And then it's gonna meet up with NADP and then the hydrogen, and it's going to make NADPH, which is a usable form of energy for our plant. And that's one source of energy for our plant. And then it looks like we're going back to that hydrogen ion that we were talking about that is being forced through the concentration gradient from the electron transport chain. It's going to go into the thylakoid membrane. Sun rays are also going to be hitting these, and then they're going to separate. The electron is going to replace the electron that left in PS2, so this process can repeat itself. And then these are going to passively transport through the ATP synthase. Inside the ATP synthase is phosphorus. So the hydrogen ions are going to grab some of those, then go back into the stroma, meet up with something I like to call ADP, which is always very nice, so very nice. And then it's going to create ATP, which is another form of usable energy by our plant as soon as Jimmy can write out that equation. Oh, it's so very nice. Very good job, Jimmy. Woo, we just finished. That is the light-dependent reaction. Here we go. Pass it on to Kevin. Woohoo!
Alright, light independent cycle, also called the Calvin-Benson cycle. Let's get started. First, we start with a 5-carbon compound called RUBP, which will accept carbon dioxide with the help of rubisco enzymes, which will turn the 5-carbon compounds into a 6-carbon compound with a higher energy level, and it is very unstable. With the process of carbon fixation, it splits into 2 identical 3-carbon compounds that have low energy but are very stable. And at this point, this is where ATP and NADP that was created in the light-dependent cycle come into use. ATP and NADP give the 3-carbon energy, which are now called pGal. This is also known by the process of reduction. So 2 pGal molecules leave the cycle that will make 1 glucose molecule. The remaining molecules return to the cycle. And 1 cycle isn't enough. The next process is called replacing RUBP. In the replacing of RUBP, in total there will be 6 carbon dioxide molecules that are reformed and processed through the cycle. This has to happen 5 more times. And that is light independent reaction.